Welcome to the lecture on geometric gradient series factor. So, in the last lecture we discussed about the uniform gradient series factor, and in that factor we were discussing about how the payments are made in uniformly increasing manner. So, the payments are increasing or decreasing by a fixed quantity, and that is why it is known as uniform gradient series and then the factor which is required to convert that gradient amount which is increasing every month. So, gradient amount is not increasing, basically that series is increasing. So, for that you will have the equal annual series calculation. Now, many a times what we see in our economic related activities, that the payment which you are making year end, they are increasing by a certain percentage. So, that is known as, so basically a geometric ratio is maintained, and that is why such series are known as the geometric gradient series, and the factors which are used for that cases are known as geometric gradient series factor. So, because in this case annual payments will be increasing by a certain factor. So, geometric gradient series factor. Now, if you look at the flow diagram or cash flow diagram of such cases, what you see is that in the first year, if your amount is what you deposit is F1, so in the second year you will be going with F1 into 1 plus G. So, in the third year, so this will be first year, second year, in the third year it will be F1 into 1 plus G raised to the power 2, and fourth year it will be F1 into 1 plus G raised to the power 3, like that. So, in the nth year you will have F1 into 1 plus G raised to the power n minus 1. So, like that you will have percentage, when there is percentage increase, basically if suppose it is increasing by 10%, it means if it is 100 rupees or 1000 rupees in the first year, in the second year it will be 1000 into 1 plus 0.1, that is 1.1 multiplied by 1000, so 1100. So, that is how it is increasing. So, that is why G is basically the percentage increase, and that way this is increasing. So, you will have basically not a linear increase, but basically it will be increasing as it is shown in the non-linear fashion. Now, for that, how to find the equivalent amount, how to calculate, and that is how how we will do it, that we will understand, try to understand in this way. So, what we do is, so what we see that in any year we get Ft at any t, it will be F1 into 1 plus G raised to the power t minus 1. So, this is what is your amount of financial transaction or money or receipt or disbursement going on, and t varies from 1 to n. So, that is how we go about it. Now, what we see is for such cases, what we try to find, we try to find the equivalent P amount for such cases, the present worth will be computed. Now, how to do that? So, you can do like this. We have again can find a table. So, it will be year, and then you will have year end payment, and then you will have contribution at present time. So, what we see is that in the first year, year end payment is we know that it is F1, and it is since we are talking about now here in this case I is the rate of interest. So, this year end payment in the end of year 1, its equivalent value at 0 time because this payment F1 is at the end of year 1. So, its value its present value will be F1 upon 1 plus I. So, that is what it is, its contribution is at present time. So, suppose you take second year and payment will be F1 into 1 plus G, and if you look at this, it is 2, there is 2 years of time. So, its present value will be F1 into 1 plus G and divided by 1 plus I raised to the power 2. So, that is how it goes. So, third year it will be F1 into 1 plus G2, and its again you will have 3 time periods which are there in between. So, it will be F1 into 1 plus G raised to the power 2 divided by 1 plus I raised to the power 3. So, this way it will go, and if you go to nth period, then as you know that it is F1 into 1 plus G raised to the power n and minus 1, and this will be F1 into 1 plus G raised to the power n minus 1 divided by 1 plus I raised to the power n. So, this is how you are trying to get the present value of all these payments which are made at these discrete times, and then ultimately we are going to get the total its contribution at the 0 time. So, this way we are going to have these values being equated and try to find its value further. So, coming to the expression, so what we can see, our expression will be, so P will be basically as you see, so P is here, this amount at which its component is taken, this will be your present amount, and that will be basically the summation of all these amounts. So, it will be F1 upon 1 plus I plus F1 into 1 plus G upon 1 plus I raised to the power 2. So, like that it will go, and it will go till F1 into 1 plus G raised to the power n minus 1 by 1 plus I raised to the power n. So, you must be clear that what is G and what is I. The I is the rate of interest at which the capital or the investment has the rate of return. So, that is that rate of interest, and G is the increase in the, so every time which is increase, that is percentage increase. So, G can be either less than I, or it can be more than I, or G can be equal to I. So, the thing is, just the example is that there is 10% of increase in the every year end payment, and the rate of interest may be 12%, or even it may be 8%, or it may be even equal to 10%. So, that is I, and G is how it is increasing. So, that that is how it goes. Now, in this case, so this is we are going to solve F1 by 1 plus I plus F1 into 1 plus G by 1 plus I2 and all that. Now, let us get it. So, now what we see is that we will further write P will be F1 by 1 plus I plus F1 into 1 plus G by 1 plus I2. So, it will go to F1 into 1 plus G raised to the power n minus 1 by 1 plus I raised to the power n. Now, if we try to see that, what we will do here is we will take 1 by 1 plus G common, so that we get 1 plus G by 1 plus I as uniform. So, in this place it will be 1 plus G upon 1 plus I plus again 1 plus G upon 1 plus I raised to the power 2. So, this way we will go up to 1 plus G upon 1 plus I raised to the power n. So, we will have this series which needs to be solved. Now, what we do is, in this case, let 1 plus G upon 1 plus I, we take it as 1 by 1 plus G prime. So, we are taking this value as 1 by 1 plus G prime. So, this P becomes equal to F1 by 1 plus G, and then we get 1 by 1 plus G prime plus 1 by 1 plus g prime whole square plus like that. So, it will be 1 by 1 plus g prime raised to the power n. So, again it is a geometric series and its first term is 1 by 1 plus g prime and its common ratio is 1 by 1 plus g prime. So, we have to add this series. So, it will be 1 by 1 plus g anyway it is here. Now, it will be a into 1. So, this will be certainly less than 1. So, a into 1 minus r n by 1 minus r, a is the first term. So, first term is 1 by 1 plus g prime, then 1 minus r n. So, 1 minus 1 by 1 plus g prime raised to the power n. So, because common ratio is 1 by 1 plus g prime, then so that will be its sum, then it will divided by 1 minus r. So, 1 by 1 plus g prime. So, this is the expression which is a whole one. So, you have a small one here. So, further you will simplify it, and what we get from here is f1 by 1 plus g, and then if you see it will be 1 by 1 plus g prime. So, this 1 plus g prime will be cut, and here it will be remaining is 1 plus g prime minus 1. So, it will be g prime only. So, now what we see is 1 by 1 plus g prime into 1 plus g prime by g prime, and then we will have 1 plus g prime n minus 1 divided by 1 plus g prime n. So, this is what we are getting. Now, in this case what we get is that this 1 plus g prime and 1 plus g prime will go. So, you will have 1 plus g prime n. So, what we see is that f1 by 1 plus g prime n minus 1 by g prime into 1 plus g prime raised to the power n. So, we can further write. So, what we get is p equal to f1 upon 1 plus g, and then it will be 1 plus g prime raised to the power n minus 1 divided by 1 plus g prime n into g prime. So, basically you must have this factor which will be multiplied with the first year payment f1, and that will give you the present worth of all these values. Now, if you look at this factor, this is a very known factor which we have already derived, and this is basically the derivation of p by a I n. So, we can write this further as f1 by 1 plus g into, and as you know that this is for the term g prime. So, it will be p by a, and this is basically interest rate will be g prime, and this is n. So, we can further write as f1 into factor p by a g prime n divided by 1 plus g. So, basically in such cases of the geometric gradient series factors, we need to know the these g prime. So, first of all what we do is we calculate g prime, as we know that 1 plus g by 1 plus I will be 1 by 1 plus g prime. So, we will calculate first g prime, then we know n. So, based on that we will have these factor p by a g prime n. So, p by a g prime n will be this one. Now, not necessarily that will be an integer g prime. So, you will have to have these values from the table, either you calculate or we will understand how we can refer to the tables for this. And once you get that, then you multiply with the first year payment and divide it by 1 plus g. In that case, it will tell us and give us the value of the p. And once you know p, then you can have any value calculated. So, this amount it will be multiplied with the factor a by p I n, it will give us the annual equivalent series, or if you multiply it with f by p I n, it will give us the future amount. So that way we can calculate any value which is required further. So, that is how we calculate, and we will have to calculate first the g prime, and then once we get the g prime, then we will have to calculate the factor, and that factor multiplied by f1 and divided by 1 plus g. Now, in such cases, there may be cases when you have the g prime which is greater than 0 or less than 0 or equal to 0. So, suppose we are talking about the cases, or now what we see is that in these cases we have 1 by 1 plus g prime is nothing but 1 plus g by 1 plus I. Now, when g prime is 0, greater than 0. So, g prime may be greater than 0. So, what does it mean? If it is greater than 0, it means 1 plus g will be less than equal to 1 plus I. So, if the g prime will be more than 0, so this value will be less than 1. In that case, this value has to be less than 1 plus I. So, this will lead to g is less than I, or I is greater than g. So, this will be the situation for the case, and when g prime will be positive, then you can directly calculate these values. You may have the factor, this factor p by a g prime n. So, we know that this is 1 plus I raised to the power n minus 1 by I into 1 plus I raised to the power n. So, I in place of I it will be g prime. So, you will be calculating that in the customary form and multiplying that factor with further with the first year payment and then divided by 1 plus g. Now, the second case may be that sometimes your g prime is 0. So, g prime 0 means that 1 plus I is by equal to 1 plus g. So, basically your I is equal to g. Now, in that case what will happen, that we know that p by a g prime n we are talking about, and p by a, so it will be p by a 0 n. So, you are giving so your interest is in fact rate of interest is 0. So, you are basically, if you look at it, this factor will be n itself. So, it is nothing but, you see, when you are giving a every year and rate of interest is 0. So, basically this factor will be n, because this p will be n a. So, if it is p, then in that case it will be n a. So, p by a p by a I n will be basically n when I equal to 0, because there is no interest rate earned. So, in these cases what we see is that p by a 0 n. So, that is why we can write p by a 0 n, that because we are calculating p by a g prime n. So, p by a g prime n, this is nothing but g prime equal to 0. So, this will be basically n. So, what we get is we are getting p equal to, we have the expression p equal to f1 upon 1 plus g into p by a g prime n, and that will be n. So, we are getting p by f1 into n divided by 1 plus g. So, when you are talking about those, so this when g is g prime is 0, that will be the case. So, I and g both are equal, rate of interest as well as the rate at which it grows, they are equal, and in those cases you can have such cases. Now there may be another case that will be the case 3, and in case 3 what we can have, it will be, so in one case G prime we have taken as positive, in another case we have G prime as negative, in another case we may have G prime as less than equal to 0, and G prime is less than 0, it means that 1 by 1 plus G prime will be more than 0. So in fact it will be 1 plus G by 1 plus I, it will be more than 0, and in that case you will have G is more than I. So that way you will have those situations, and we can discuss these situations, we can solve the problems based on that, and we will be calculating these values, and then we can find whatever we require to find out. Now in a nutshell, we have discussed about the different type of factors which are used, and they are compounding amount factors. We have used the present single payment factors, we have used the annual equal amount series factors, we have also used the gradient series factors, among that uniform and you have the geometric gradient series factors. So if you try to look at the these factors one by one, what we see is that we will see that there will be some relationship between these factors. For example, if you talk about, so what we have seen is that we have f by p I n, and this f by p I n is, as we know, that it is 1 plus I raised to the power n. Similarly, the p by f I n is it is 1 by 1 plus I raised to the power n, or 1 plus I raised to the power minus n. Then you have f by a I n, and f by a I n we know that it was 1 plus I n minus 1 by I, and a by f by I n, that was equal to I upon 1 plus I n minus 1. So similarly, you have p by a I n, and that was 1 plus I n minus 1 upon I into 1 plus I n, and similarly a by p I n, it was I into 1 plus I n divided by 1 plus I n minus 1. Now if you look at these formulas, what you see that there will be you can have certain relationship between these factors. For example, if you look at this f by p I n, that is 1 plus I raised to the power I n, and then if you look at this f by a I n, this is 1 plus I raised to the power n minus 1 by I. It means that if this factor is multiplied with I, if this factor is multiplied with I, so it will be 1 plus I raised to the power n minus 1, and then if you add it with 1, then it will be same as this factor. So what we see is that the first expression is this factor multiplied by I. So we are equating f by p I n. This will be nothing but I times this factor, and then so I times f by a I n, and then we have to add 1, so that this 1 is cancelled. So this is how you can have one factor. So if you know one factor and you have to know the second factor, you can directly use. So if you know f by p, you can directly find f by a I n, provided I you know. So certainly you know I and n. So by looking at this relationship, you can find these factors. Similarly, go to the next one. You look at the factor p by f I n, so 1 plus I raised to the power minus n, and you look at the factor p by a I n, that is 1 plus I raised to the power n minus 1 by I into 1 plus I n. Now if you look at this expression like p by f I n, now this 1 plus I raised to the power n, Now, if this factor is multiplied with I, so it will be 1 plus I raised to the power n minus 1 by 1 plus I raised to the power n. Now, you subtract it from 1. So, what will happen that 1 plus I n minus this one. So, only 1 will be remaining. So, it will be 1 by 1 plus I raised to the power n. So, that is how you get it. So, you are getting, so what you do is you are multiplying this p by a I n with I, and you are multiplying with this. So, what you see is that this, when it multiplied with I, this I will vanish. So, you will have this term, and when it is subtracted from 1, then this 1 plus I n term will go, and you will have only one term remaining, 1 by 1 plus I raised to the power n, and 1 by 1 plus I raised to the power n is nothing but p by f I n. So, you are getting this as the next relationship. So, once you know one factor p by f I n, you can find p by a I n. So, this expression can be further used. Similarly, you have the expressions like f by a I n. Now, this factor, if you look at f by a I n, it is 1 plus I n minus 1 by I. Now, this will be 1 plus f by p I 1 plus it will go, and it will go up to f by p I n minus 1. So, if you see you know, as you know that f by p is 1 plus I. So, it will be 1 plus I plus, like that it will go, and if you add, it will be 1 plus I n. So, it will be you know, f by 1 plus I n minus 1 upon you know, I. So, that you will be getting in such cases, because it will be geometric series. So, now one you know, r n minus 1 by r. So, r will be basically, so r minus 1. So, it will be I remaining in the bottom. So, this way you will have another. So, this way you, if you try to find, you will be seeing that a by f I n. Now, this will be a by p I n. You can see a by p I n minus I. A by p I n, if you look at this, and if you subtract I from this, so this term will be vanishing, and it will be I upon 1 plus I. So, this will be a by f I n, I upon 1 plus I raised to the power n minus 1. So, we discussed. Then next we can have further some relationships. We may see p by a I n. Now, p by a I n, if you look at you know, p by a I n is this, and if you try to see this in terms of p by f I n. So, you can write that it will be equal to p by f I 1 plus p by f I 2 plus p by f I n up to go, it will go up to I n. Now, you can check from this that if your this series is increasing, in that case 1 plus I will be, you know, going up like 1 by 1 plus I will be going on. So, you will have this as the first term, and 1 by 1 plus I is also the common ratio. So, that will be further you know, going into the bottom, and if you try to see by, if you do the algebraic you know, analysis, then you will find that it will be coming as 1 plus I raised to the power n minus 1 by I into 1 plus I raised to the power n. So, this is another formula which will be utilized in the long run. Then you will have a by p I n. Now, this is equal to I upon 1 minus p by f I n. So, if you look at this p by f I n, now this a by p I n, we know that this is you know, I upon into 1 plus I n by 1 plus I n minus 1, and this is p by f I n. So, p by f I n, we know that this is 1 by 1 plus I n. So, it will be multiplied, 1 plus I n will go up, and 1 plus I n minus 1. So, that way it will go and it will become a by p I n. So, as if you look at this one, so I upon 1 minus p by f is 1 by 1 plus I n. So, it will be coming like I into 1 plus I n by 1 plus I n minus 1. So, that is what it is coming as from here. So, in fact, you can do all these calculations and you can find this, and these expressions will be useful for finding the factors. Although you have to calculate these factors whenever required by using these formulas, but as you grow, as you go towards the chapters where you need the frequent values calculations and all that, or you want to have many factors calculation, at that time you are going to refer to the table, and that table is basically the interest table. So, not interest table, you can say factors table basically. So, the factors are seen. So, what is there in that? Basically you will have I n given like this, and then you will have for particular I you will have a table, and all these factors f by p I n, and then a p by f I n, then f by a I n, a by f I n, all these values are basically given. So, 1, 2, 3, 4, 5, 6, and you can go and for a particular interest, suppose say 3%, you can directly get the value from here. So, this value will be used from that interest table, and we will see also that how to find directly these values from those tables. So, that way we will calculate. We will also talk about the different interests, and that will be more clear when we solve the problems and use these tables for solving the problems. Thank you very much.